diameter of 24 inches. The hands on the clock show a time of 4:45. First question, what is the radian measure of the angle formed between the hour and minute hands? So if I make a rough drawing of a clock here, we're assuming this is a circle-shaped clock, okay? So we have our center here. We have the hour and minute hands. So remember, on a clock you have your 15 minutes, half hour, 45 minutes, and then we have each hour. We have 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, and then 10, 11, and back up to 12 o'clock. So there are 12 divisions around this circle. Okay. Our time says 4:45. So 45 minutes means the minute hand would be pointing over here. Okay. 4:45 means that our hour hand would be approximately pointed towards the 4. And assuming it moves continuously, 4:45 means that it wouldn't be exactly at 4 o'clock. It would be 3/4 of the way over. So like the first 15 minutes, it would move here, the hour hand. At 4:30, it would be here. And at 4:45, it would be approximately here. That's assuming that our hour hand moves continuously. And then when we get to 5 o'clock, it's here. Okay, so it doesn't suddenly move from 4 to 5 right at the hour. It gradually moves along. But 4:45, we're assuming it's gone 3/4 of the way there. Let's start by breaking down. We want the radian measure of this angle here. Okay, so let's start and see how many full sections, hour section. We have 1, 2, 3, 4 of them that were covered, and then another 1/4 that was covered. Okay, to get to our 4/4 from the 4 hour to the 45. Okay. Well, how much is each section worth in radians? How much in radians? Well, how many radians are in a full circle? Hopefully you said that 2 pi radians make a full circle, because it does. And we have 12 sections created by our hours, our 12 hours on the clock. So we're going to take our 2 pi and divide it by 12. Okay, that is going to give us, I'll just put it in fraction form and reduce it, pi over 6. So each of these sections is pi over 6 radians from the center of the circle. Its angle measure is pi over 6. How many full sections do we have? We have 1 here, so that would be pi over 6. Here's another pi over 6. Here's another pi over 6. And here's another pi over 6. This last little section, notice, is only 1/4 of a section. So how much is that? Well, if we take pi over 6 times 1/4, we get pi over 24. Okay. If it were half, we would have done pi over 6 and cut it in half. If it were 3/4, we would have done it times 3/4. But it was only 1/4 there. So our radian measure of our angle, we have pi over 6 4 times. So you can do 4 pi over 6, or you can add them 4 times. It's up to you. And then we had plus another small wedge, pi over 24. We're going to add those together. So a 6th, a 6th, a 6th, a 6th, and then a 24th. Okay, that's 4 pi over 6 plus pi over 24. If I get a common denominator here, I would do that by multiplying by 4 and by 4. And you probably have a fraction button on your calculator and you're way ahead of me. If not, we'll go through this, because I know fractions for some people are just harder. Okay, 16 plus 1 gives me 17 pi 24. The radian measure of my angle is 17 pi over 24 for that situation. Now you could do this all in degrees, but remember they wanted the radian measure. So after you get your degrees, convert it to radians. All right, that's part A. That's our angle measure. Part B says if the hour and minute hands were each extended to reach the edge of the clock. So we're assuming that from the center here, we extend them so they create an intercepted arc. Okay. What would be the length of the arc from the endpoint of the hour hand to the minute hand in the clockwise direction? So that just solidifies that this is the portion we're working with. We want the actual arc length. The formula for arc length is S stands for the arc length, I know, weird, is the radius times the angle theta, which is the radian measure of your central angle. We found that. We know that it's 17 pi over 24. So part A comes in handy. All we have to do is multiply that by the radius. What is the radius of our clock? Be careful here. It said the diameter was 24 inches. We want the radius. Remember, radius is half of that. So our radius is 12. So to find our arc length, we're going to take 12 times 17 pi over 24, and we're going to go ahead and write the decimal answer there. So 12 times 17 times pi, and then divide by 24. When we do that, we get about 26.7 is the distance on the edge of the clock from the minute hand to the hour hand.